In this video, we'll look at some of the logic that we can use within iMath question writing. So one very important construct in really any programming language is if-then statements. And iMath allows you to write if-then statements, which is very useful. So as an example, I'll just write a sample one here. So we could say if true, and then we're going to put curly braces to indicate what we're going to run if true is true. Then we'll just say something like $A equals true value. Just put some kind of string there and we'll display that out. So then within our question text, we'll just put $A so that we can see what the value of this variable A is. So if we quick save and preview, over in the student preview, we should see true value. And that's because what we input into this argument of the if statement is some kind of Boolean value. And if the Boolean value is true, or true in nature, then we're going to run whatever's inside this curly braces. And then if it's not true, then we just don't run what's inside of here. So if we instead said if false, then that line is not going to run. And so we're not going to see anything in the student preview because A is not being defined. So another common thing to do is if some Boolean value is true, then we run some statement, and we do else with curly brackets. And then we tell the system what to do if that statement is not true. So then we could say something like $A equals false value. So if false, so we'll change this back to true. If true, then A equals true, otherwise false value. So we have true value. If we change this Boolean to false, then we could quick save and preview, and we see false value. So in this way, we can control what we do based on the value of some Boolean value. And we usually don't do something like if true or if false. It's actually not very interesting. We should look at like a more interesting example of this. So one example that I kind of like to do is maybe we create some variable, we'll call it x, and we'll give x a value of 17. We'll just pretend like x is some integer value. And what we'll do is if x, and then if we do a percent sign, that is the modulo operator. So if x modulo 2, if that is equal to 0, then x is even. So we could say that, we'll just say x is even. And then if that's not true, if x modulo 2 is not equal to 0, then we can say x is not even. So if we quick save and preview, we see that we get the statement 17 is not even. Cool. So we change x to a value of 18 and quick save and preview, we see that 18 is even. So this is like a more realistic scenario where we add some kind of comparison or condition, and if it evaluates to true, then we're going to run the first block. Otherwise, we're going to run the second block. So we should take a second to cover some of these types of comparisons that we can look at. So we have a handful of logical comparisons that we can make. So I'm going to change this first value of A to true block run. And then in the second one, we'll do false block run. And then we're just going to change the statement up here a little bit. So we have a handful of comparison operators. If we're comparing numbers, we can use like less than or greater than. So we can do something like 3 is less than 5. That's going to evaluate to true. So if we quick save and preview, we're going to see true block run. On the other hand, we could do something like if 3 is greater than 5, then we run it. Otherwise, we run false block run. And so we see false block run because 3 is not greater than 5. So we have a handful of things like less than or equal to, greater than or equal to, less than, greater than. Another important one is if we want to test whether two values are equal, then we do double equal sign or triple equal sign. There's a difference within programming. I won't discuss the details too much here, but usually if we do triple equal sign, we can compare two values. So if we did something like if x is equal to 18, then we're going to run the first block, otherwise we'll run the second one. So we see true block run, Now, if x had a value that's not equal to 18, like 18.1, and we run that, then we're going to get false block run. So we have these equality comparisons. If we want to check whether or not two values are not equal, so like if we want to ask, is this value not equal to something, we can do exclamation point equals or exclamation point equals equals. Either one of those two things should work for our case. So now if we say if x is not equal to 18, then we're going to run the true block. So we see that the true block is going to run over here. So those are some of the important ones. There's some more details on this in the question writing help, but those are probably the main ones that you're going to use. Okay, so in the spirit of this if-then type of statements, there's a nice operator in most programming language called the ternary operator. So most of the operators that we use in math are binary, like addition, subtraction, multiplication. There's actually a ternary one in programming that's really nice to use. So this block of text that we have here, this block of code, says that if x is not equal to 18, we're going to have a have some value, otherwise b is going to have like this other value. So we could actually condense that and do $a equals, and then what we're going to first put is our comparison. So we'll do x not equal to 18, and then we're going to put a question mark, and then the second input is going to be what value we want if this first argument is true. So in that case, it's going to be true block run, and then we do a colon. And then the third argument is what we want the value of a to be if that first input is false. So then we'll do false block run. So I'm just going to delete out this. So we'll just delete that out of there. But what we're going to see is we're going to have the same thing happen. So we get the same output over here. This is just like a condensed way to write that previous if-else statement. So these ternary operator, which is kind of like the $colon, basically allows you to provide some kind of comparison or anything that gives you a Boolean output. It'll return the second input if that first input is true, and it's going to return the third input if the first input is false. So this is a very useful thing. Okay, one last thing. I know this video is already long, but there's a lot to cover here. We'll look at for loops. So in programming, it's really nice to loop and like repeat some operation a handful of times based on some kind of pattern, because typing out the same statement over and over again is not very efficient. So what we're going to do is I'm going to create a variable a. It's going to have a string value that's currently empty. And just as a simple example, we could do for, and then we're going to provide a variable name, I. Usually we use I for iterator. So we'll just say I equals, and then we're going to do 0, period, period, and then we indicate basically how many loops we want, or what the starting and ending values of I are going to be. So this first 0 is what we want I to start with, and then we do dot dot, and then what we want I to end with. So we'll go from I equals 0 to I equals 18. We'll put some curly braces, and what we're going to do is take A, and each time we loop through this, we're going to append to it. So we'll say A equals A, and then we're going to concatenate or glue a new value of I to it. So this line right here essentially says, now we're going to say A is going to be equal to what A was, but then we're also going to glue on another piece of string that just has the new value of I in it. So if we save this and we preview it, we see that we have 0 all the way up to 18. So basically whatever's inside of these curly braces within this block, that's just going to run a handful of times, starting with I equals 0 and ending with I equals 18. So this can be a useful thing. I'll show some more actual like real world examples of this in upcoming videos.